Cristian, Fabi, Cristian, estos andan por allá.
When we were going to the moon in the late 60s, early 70s, we had this thing called the Saturn V rocket. 3,000 tons, 363 feet tall. The only thing that ever came back was the capsule, and you couldn't even use that again. So after the moon missions, pressure's put on NASA to find a way to go into low Earth orbit, meaning 115 to 450 miles up, and reuse as much of the technology as possible. So the design that you're all familiar with is this one. You have the orbiter, which most people call the shuttle, but really the whole package is a shuttle. The orbiter has 3 engines in it that burn liquid hydrogen, liquid oxygen. The fuel for those engines is carried in that brown tank, and the orbiter hangs on that tank. There's 2 solid rocket boosters that also hang on the tank. So the orbiter comes back and lands on a runway. The boosters are parachuted into the Atlantic, recovered, refurbished, reused. The only thing that's not reused is that orange tank. It comes down over the Indian Ocean, breaks up, some of it burns up, the rest of it goes to the bottom of the ocean. Now, we built 6 of these things. The first one was Enterprise, which used to sit here. It's now at the Intrepid Museum in New York. That never went into space. It just glided off the back of a 747 to see if they could fly and land it. It had 4 flights. We lost Challenger, we lost Columbia. This is Discovery. Atlantis is down at the Cape. And Endeavour sits at the Science Museum in California now. 135 total missions flown between all of them. This one flew 39 of those. So this is the granddad. It flew every kind of mission imaginable. It took up military satellites, it took up commercial satellites. It brought satellites back down to be repaired. It repaired some on some of the missions. It took up the Hubble Space Telescope. It flew 2 of the servicing missions to Hubble. It took up military payloads. It went to the space station Mir at least once. It took up a lot of the materials to build the International Space Station. So it's really done it all. And it looks like it. It looks like it's been well used. Now, again, heat is the big issue during re-entry. Not going up, but coming back. So there's different levels of heat protection all around the airframe. The worst areas are the nose and the leading edges of the wings that encompass temperatures of 2300 plus. And that's covered by something called carbon, reinforced carbon. The black tiles handle temperatures up to 2300. The white tiles and the white quilts handle temperatures up to 1300. Now, white quilts were substituted for white tiles. They found that the quilts could take more of the torquing and twisting than a lot of the white tiles could, so they began to substitute quilts for tiles, white tiles. And on the top of the fuselage, you got something called Nomex felt, which handles temperatures about up to 700. Now, if you all have, I'm sure, seen on the news, when they bring this up to the space station, they turn it all around so they can look at the bottom of it, see if any tiles were missing. Well, they do that through the use of thrusters. Those 3 engines burning hydrogen and oxygen are shut off when they're up there at that altitude. They don't get turned on again until they're on another space mission. But they use 46 thrusters. These are thruster ports here. There's ports all over the nose of this thing and the tail end, so they can move this thing in any direction they want. And that's how they do that twisting, that turning motion when they go up to the space station. The tiles. The tiles are 1 to 4 inches thick. Every tile is unique. Each tile is unique to the ship and its position on the ship. Which makes it a highly expensive proposition. The tiles are almost like spun fiberglass. They're 90+% air. So that the marking you see here, all this lettering, that identifies the tile, the ship, where it is on the ship, and its batch of material it was made from. The little mark in the center, that's not a screw that holds it to the frame. It's actually glued to the frame with an adhesive. That is a point where a human being, after every mission, has to come up with a device that I've never seen, but it must be the biggest hypodermic needle in the world, and they inject waterproofing fluid into that tile after every mission. 24,000 tiles, 1,500 quilts. Because when this thing sits on the stand out there in Florida, it's subjected to all this rain, humidity. It needs that waterproofing fluid. But when it makes that fiery entry to come back through the atmosphere to Earth, all of that stuff burns off. I had an engineer describe that material, that fluid is like something like Scotch-Guard. Now, early pilots, early mission members had some interesting stories to tell. Before we ever had a space station, this thing would go up with laboratories in the back end. It could carry something the size of a school bus. You'd have 7 or 8 guys on board, or women. So this thing has to provide facilities for them to live and operate and function for a period of 2 to 3 weeks. So think about it. It takes off as a rocket. It takes stuff into space, it takes people into space, and it comes back and lands as a glider. No power. To me, it's a rocket-powered Winnebago truck. It just can land as a glider. That's probably why we had so many problems with it. But early mission members had some interesting stories to tell. One of the early pilots said, you know, when you see this thing take off, I've never seen a live shot, but I've seen plenty of film. It starts moving ever so slowly. You don't think it's ever going to get off the pad. He said there ain't nothing slow about it. It's like a giant hand has grabbed you and thrown you from 0 to 17,500 miles an hour in 8 minutes. They found that they began to have backaches when they first got up there. Everybody had a lower backache. And we learned that the spine relaxes, the muscles in the spine relax at a different rate than some of the tendons or muscles around it. And it seems to affect men more than women. So everybody's looking for the Motrin after you get up there, for these lower backaches. You lose your sense of taste in space. So everybody's looking for spicier foods. Packets of taco sauce were put on cereal. Packets of taco sauce were as good as $50 bills up there. One pilot tells us a story. He came back with a crew member. They're given physicals as soon as they get back. He's in the doctor's office. The doctor says, would you like a glass of lemonade? Sure. He gives him the glass of lemonade. The guy's holding the lemonade, and he sees that one of his shoes are untied. And he immediately does this. And starts to tie his shoe. Forgot where he was. John Glenn flew on Discovery. You know, first American to orbit the Earth. He was 77 years old as a senator flying on Discovery. And I'm sure he was on the right committee that NASA wanted to give him a ride. So the 4 crew members, there were 4 experienced members, Senator Glenn and a Spanish astronaut were the 2 newbies of the group. They decided to have some fun with them. They had boarding passes printed up. And they had the suit technicians put the boarding pass in a certain pocket of the trousers. And then they took a SWAT team and set them up all around this hatch here. When the commander comes up, he's the first one on board, pulls his boarding pass out, gives it to the SWAT team member, and he goes aboard. The other 3 guys do it. Here comes Senator Glenn. They said he had the suit practically off, looking for that boarding pass. He couldn't find it in any pocket. But I'm sure he was on the right committee. Let's start down the side here. I want to point out a couple of other things to you. Then we'll go to the back end. A couple of things to point out. Notice how these quilts are dirty, and you can almost see a line that goes like that. That's not Florida dirt. That's from the searing of 39 re-entries right through the atmosphere. This little hole right here, remain open at all times. On the very first mission, Discovery went up, and after a period of time, after they realized we're developing the world's largest yellow icicle right here. So they just rolled the ship, exposed this area to the sun, softened it up for a while, and then used this multi-million-dollar Canada arm and knocked it off. looking at the back end here. Let's look here. These original cones, those are the original cones I discovered. These little tubes that you see running around, that's where liquid hydrogen comes from. You can see more thrusters here. That's a very large thruster, the one on either side of an Ohms spot. I'll tell you how much you can get. This right here is called an umbilical patch. This thing begins to leave the launch pad. This starts to move, those things get yanked off and goes up. It's through this umbilical patch that have electric power communications with the crew while it's on the stand. It's also how they fill the fuel tanks. Hydrogen, liquid hydrogen comes in here, the swivel burn comes out there into the tank, where it's hanging on the tank. So they fill the tank through the orbiter. Oxygen comes in through the other side. Here's where the brake and chute is carried. That little white box there. Right there. Now these Ohms parts. This is interesting. When they're flying around and they want to land, they're on the other side of the Earth. They're upside down looking at the Earth. Well, they don't want to start coming down this way, nose first. So they use those thrusters to turn themselves around. Then they fire those heavy-duty thrusters, those old big Ohms pods, to break their orbit. It comes down out of the orbit like this. This is the bottom of the ship still. So all of those black tiles start to catch that heat. As it rotates over, it comes into land. I would love to be in this thing as it's going through that maneuver. I can't imagine what that must be like. Never want to be in an airplane up at that altitude, maybe. Come on underneath it. As I mentioned, it hangs on the orange tank. There's an attach point from here down to the tank, one over here, and there's two inside of the nose wheel down here. I mentioned they fill the tank through the orbiter. Hydrogen comes in through here, oxygen over here. You've all seen the tank fall away on the news footage. All the debris flies away because there's a camera port right here that records that. Once everything is cleared, these hatches get closed, never to be reopened, so they're back down on Earth. Now, tiles. They lose on the average of about 150 tiles a mission. And they're more vulnerable along hatch openings. I guess I can understand that. Catches some, things are moving in that area. So that's why you can see newer tiles around doorways. The tiles are arranged in this herringbone pattern with a purpose, that if something were to let loose up here, it might not rip the whole length of the ship. And they're held on with an adhesive. I don't know what we would do if we were to design the shuttle today and build it. I gotta believe something better than this would have been the solution. But I don't know what it would be. I'm not an engineer either. Any questions about the shuttle, I might even try to answer for you. Okay, let's just back up a bit here. I want to give you some perspective. 1958, we launched our first satellite, we the U.S. Got the sun here, the sun's bad. Okay, that's okay. Here's what that Explorer 1 satellite, see that little pencil tube up there? That was a 31-pound satellite attached to the last stage of the rocket that put it up there. That's 1958. Up until a couple of years ago, 250,000 pounds of this went up, fully loaded. Now, can you hold that for me? Here, let me show you my famous string trick. If you start getting interested in astronomy or space, one of the things that really struck me when I first started reading is there's so darn much of it. And the distances are staggering. Oh dear, this is not going to work. And the distances are so staggering, or the numbers are so staggering. First off, you've got, the astronomers tell us, scientists, there's over 100 billion galaxies. Now we live in one of them, the Milky Way galaxy, okay? But there's 100 billion, over 100 billion. And within each of the 100 billion, there's somewhere between tens and hundreds of billions of stars. Well, already I can't handle that math. I can handle, we're used to one star here, our sun, in our little solar system here in the Milky Way galaxy. Well, we know that planets travel in elliptical orbits around our sun, and we average them out, we can get a radius. And that's what I'm attempting to do with this string, is to give you a radius, to give you some sense of the distances involved. You look at a night sky, you can see airplanes flying, you have some sense of how high that is. Maybe you've seen the shuttle go over in the early evening, you see some reflection of that, you can see that's a lot higher than the airplanes, and you got some sense of the moon out there. Okay, if this is our solar system, and my fist is our sun, that's our star, that first knot out there is us, that's Earth, 93 million miles away. Takes that sunlight 8.5 minutes to get to us. Way out here, and the Kuiper Belt is where Pluto lives, that other knot. I believe it's about 3.3 billion miles out there. We just sent a spacecraft. We had a spacecraft just do a flyby of Pluto, the New Horizons spacecraft in July of this year. It left this first knot 10 years ago and got to this knot in July of this year. To get to the next star, our nearest star is our sun, but to get to the next nearest one, Proxima Centauri, on this scale, I'd need a ball of string 4.5 miles long. I can't fathom that. Oh well. I got one more picture to show you. Let's see if anybody recognizes this man, and then I'll let you go to lunch. Okay. Anybody know this man? It's not Lindbergh. What's that?
Final liftoff of Discovery, a tribute to the dedication of
Okay, you're going to have to hear the story. He's born about 1763 in England. His father is a member of British royalty. His mother is not. So he goes off and lives in exile in Paris, I guess. He studies metallurgy, geology, chemistry, and he writes in his will that his entire estate shall go to his nephew. But if my nephew dies without any heirs, my entire estate shall come to the United States of America to found in Washington, D.C., the Smithsonian Institution for the increase and diffusion of knowledge. His name is James Smithson. Well, as you guessed it, the nephew had no heirs. The U.S. sends a lawyer over to England about 1850, liquidates the gentleman's estate, brings back $500,000 roughly, and with that they start to build the red brick castle down on the mall. I tell you this story for two reasons. One, I think it's incredible anybody would do something like this, and he never set foot in this country. Mr. Házy, who donated a lot of this building to get it started, he at least got here and made a fortune doing it, for which I'm very grateful. But this man never set foot in the country. And the other reason I tell you the story is, when you get to that point in your own lives, when you're doing your own estate planning and writing your own wills, remember what James Smithson did. Thanks a lot. Come on, there's a lot more to say. A lot more military airplanes we never even touched. Take care.